exercise 2, which is finishing off the optical physics concepts we discussed earlier. So exercise 2, optical physics, part A of it states derive equation 3 for Gaussian optics from equation 1 by approximating cosine phi. Cosine phi in equation has jumped. So in equation 2 by its first degree Taylor polynomial. So yes, basically derive that equation 3 using that cos phi equals to 1. So in equation by its first degree Taylor polynomial. So basically we're gonna approximate. We're gonna plug this. This is equation 1. We're gonna take equation 2, approximate equation 2 over here using cosine phi is equal to 1, and then plug that inside equation 1, and then we're going to get equation 3. So we're actually going to try to solve this out using that approximation. So let's keep going further. So inserting equation 2 with cosine phi is approximately equal to 1. That is approximating it with its first order Taylor polynomial. Into equation 1 we get, let's do this all in one go, so L naught is equal to, this is this giant square root function, and let's see if we remember it. It's going to be r squared plus, and it should be s naught plus r squared minus 2r, multiply the sides, 2r, and then s naught plus r, multiplied by s naught plus r, s naught plus r, and then times it by cosine phi. And let's just go and double check this was correct, and it should be. Let's just scroll up to equation 2, which is these two right here. So this is the first one. L naught equals to r squared, giant square root r squared plus so plus r all squared, then minus 2r so plus r times cosine phi. And the next one's going to be si minus r, and then it's going to be a plus here. So as opposed to a minus, it's going to be a plus. And that's the only difference. It's going to be a si minus r and then a plus. So let's keep going further. So this is correct right here. So now this part, we're going to approximate this with equaling to 1. So that means this is going to equal to, approximately equals to square root, put a giant square root, r squared plus s, and let's just expand this out. So so plus r squared, so this is going to be foiling it out. So so times so, so squared plus so times r, then r times so, that's going to be 2 so times r. So you should be able to do this foiling method in your head if you've gotten this far in this video or my channel. This is going to be plus r squared, so r times itself. And then the next one's going to be here. We're going to multiply these inside. It's going to be negative 2. Negative 2r so multiplied inside, and then negative 2r squared. And now let's see what we can cancel. So we have a bunch of 2's there. So this r squared, and this one will cancel with, this r squared and this one will cancel with these two. So that's gone. And now this 2SOR and this minus 2RSO, those are the exact same thing. So these cancel. All we're left with is this one. So we're left with now, this is again equals to, so now this part will equal to square root of SO squared. Now this equals 2 plus or minus SO when you cancel all the square roots, and there's also plus or minus because you could also have a plus or minus because the square cancels it out. But again, we're talking about positive, we're only going to be considering the positive distance in this equation, so it's going to be SO, like that. So then LO is equal to SO using the approximation. And then similarly, the LI, this one is equal to a giant square root, R squared plus, so R squared, and this is going to be R squared SO plus R squared. This is going to be SI minus R. Remember, the equation is going to be the minus. We have to do the SI minus. Let's move this, and then it's going to be a plus after that. So plus 2R, multiply the sides, SI minus R, and this squared is outside, not inside. This is going to be 2 like that. SI minus R, then cosine phi, and again, where this equals 2, approximately equals to 1. So thus this becomes an approximation, approximately equal to square root and then we get an r. Let's make this a bit better sign. Like that. Should be a bit better. Yeah, so now it's going to be an r squared plus, and now si times itself, si squared, and the si times negative r. The negative r times si is going to be 2 si when you add those up, r when you FOIL it out. Then negative r times negative r is going to be plus r squared. Now the next one's going to be plus, multiply these all out, 2r si minus 2r just 2r squared. 2r squared. Now notice again, there's an r squared, and a negative 2r squared. Those all cancel. Now again, we have a 2r si. This cancels with this, and now we're just left with this one. So that equals 2. This equals to square root of si squared, which equals 2 plus or minus si. And then this equals 2. We just take the plus side because it's positive. And yeah, the positive distance. And yeah, we get si like that. Yeah, so thus what we get is, well, thus, now we plug this inside. So now our formula, our initial one's going to be our ni, or n1 over n2. I mean n1 plus, let's just go back to this one. Let's go back to equation 1. Yeah, so here is equation 1. So n1 over L0 plus n2 over Li, then we have 1 over r. Then we have n2 si divided by Li, then minus n1 so times Lo, like that. And the 2 and s and the I are corresponding, and then there's a 1 and there's so, like that. Anyway, let's go back to here. So let's write this down. So thus ni over Lo, and then plus, this is going to be, the next one's going to be plus n2 over Li. This equals to 1 over r. This is just equation 1. And then times it by n2 si over Li minus n1 s naught over L naught. So that's equation 1. Now we plug this all inside, so we have our LOs. And yeah, so our LO is equal to SO. That's LO equals SO. LI equals to SI. So let's just write that all down. So thus we get, thus that equation becomes, so it just becomes N1 over SO, like that. So the distances become the flat ones. Let's write this a bit better. Plus N2 over SI, which equals to now 1 over R. Yeah, this is going to become, well, when you plug in Li inside here, this is SI, these just cancel. So I'm going to put this as R like this, and times it by N2 times SI over Li is SI. So this cancels, minus N1 SO, L, this is going to be L, SO. This cancels. So we're left with is this equals 2. I'm just going to put this all in one go. N1 over S0 plus N2 over SI, like this. Erase this. And this equals 2 N2 minus Ni over R. Now this is exactly equation 3. Whoops, let's make this a bit better. One more time. Okay, that's perfect. Okay, this is a check mark. We can see it. So N1 divided by SO plus N2 divided by SI equals to N2 minus N1 divided by R. Let's see this again. Yeah, let's just scroll up to equation 3. So there's equation 3. So N1 over SO plus N2 over SI equals N2 minus N1. So divided by R. Exactly as expected. So let's keep going further. Let's look at part B. Alright, so now, yeah, let's look at part B, and here's part B. It says, show that if cosine phi is replaced by its third degree Taylor polynomial in equation 2, then equation 1 becomes equation 4 for third order optics. So again, same thing, but now we're going to use the third degree as opposed to the first degree. And again, recall that the third degree, let's just scroll up to it. The third degree is over here. It's going to be just 1 minus x squared over 2 factorial. So instead of 1, we replace it with x squared minus 1 minus x squared divided by 2 factorial, and it's a third because the third one is 0 there. So yes, fascinating stuff. So this third is the same as the second in this case. So let's just do that again. So, and I have this ingrained into my brain, so I can do this by memory. So L naught equals 2 r squared, then it's going to be r squared plus r plus, this is going to be SO, like that, squared. Or actually, it was written the other way around. S naught plus r squared minus 2r SO plus r, and then this is cosine phi, like that. Now we're going to replace this part right here, so this one's going to be roughly equal to 1 minus, this is going to be 1 minus phi, so then instead of x squared, instead of x, this is phi, so phi squared over 2 factorial, which is just 2. So just leave it like that. Alright, so this means then this can be approximately equal to, and let's just save some time by expanding what we already have. So r squared, and this one's going to be, expand this out, just FOIL it out, is the s naught squared plus 2s naught r plus r squared. Now we're going to, let's just multiply this inside. We're going to have a 2r SO, put this in a bracket, plus, does we have minus, actually, I'll just keep it as plus, so you keep the negative out of there. So plus, this is going to be 2r squared. And now we're going to multiply this whole thing out by 1 minus phi squared over 2. And make this squared bigger to account for all this. Make this, or just make this a bit smaller to make it a bit more neat. It'll be 1 minus phi squared over 2, like that. And now we just got to multiply these inside there, and also this 2r squared, let's just add those up. This is going to be equal to, like this is 2r squared plus s naught plus 2SOR. So yeah, this one's we just add with this. And now we're going to multiply this inside. So this one, we're going to FOIL this out, and there's a negative sign, so negative 2r SO, 2r SO multiplied by 1. And then multiply it by this negative phi squared over 2, but they also have a negative there. So it becomes a positive. So we multiply this by that and this by that. Now it's going to be a positive 2 over 2 RSO times it by phi squared. Now the next one's going to be over here, 2r squared. So plus, but then there's a minus 2r squared minus, then multiply by this and by that. Minus 2r squared, and then just keep, this one's got to expand further, further like that, and now we're going to multiply it by, inside this negative 1 there, but there's a positive there, it's going to be negative times a negative, it's going to be positive, 2 over 2, just keep the 2 over 2 just to show that they cancel, then this is going to be r squared, phi squared, like that. So now what we have is, let's see what ends up canceling. Yeah, so we get, well, this 2r squared is going to cancel with this negative 2r squared. That's the obvious one there. Now we have a plus 2 SOR and a minus 2 RSO, the same thing. Those cancel. So now what we're left with is, and also these 2's cancel. These 2's cancel. We're going to be left with, right here is going to be, this is going to be equal to square root, and this is going to be, well, all we're left is this one. And this, and this. So we're going to be left with SO squared, and then plus RSO phi squared, and then plus R squared phi squared. So that's what we're left with right now. And now let's continue further and now look at the Li. So the Li is equal to square root, and then we're going to use the same approximation. And this is going to be r squared plus, remember this one's going to be si minus r, all squared, and then it's going to be plus 2r, and then si minus r. And now let's just do the approximation now, and let's just save time. So this is going to be approximately, and this is going to be 1 minus phi over 2 squared. So that's the third degree approximation. Just block this out. and expand this. Alright, so we have that. And yeah, it's not a squared there. This is a squared inside and out. Yeah, so that would change everything, make it much more complicated. So that's what that one is. And let's start doing the next steps. So next step is going to be square root. Now we're going to have an r squared here plus, this is going to be 2s, just si squared, so expand that out, minus 2sir squared. And the next one's going to be plus r squared when you expand this out. And then the next one's going to be plus 2r si, then multiplied by 1. Plus 2r si, then multiplied by 1 by itself. Next one's going to be 2r si, so just multiply these together, and then multiply by the 1, then multiply by the other one. We already did the 1. So it's going to be, now it's going to be negative 2 over, yeah, so negative 2r si over 2, and this is going to be phi squared. Next one's going to be 2r times negative r, and then times it by 1. So this one's going to be times it by, well, this and this. Let me just circle this. This one, and then multiply by this and that. So it's going to be plus 2r squared, 2r squared, and then it's going to be 2r squared. Yeah, it's going to be a negative there. So we have to include the negative. Negative 2r squared. So negative 2r squared, but there's a negative there, it becomes positive. So negative 2 over 2, it's going to be r squared, and then phi squared. When you multiply by this one, there's a 2 there. And that is it. Let's just expand this. Alright, so now that we have this, let's do some cancellation. So we have this this r squared, and so this one will cancel with these two. Yeah, so those two r squareds will cancel with this negative 2r, negative, yeah, 2r squared. Now the next one is going to be negative 2sir. Will cancel with, well, this one here. Just 2r si is the same thing. Now these ones will cancel, and then all we're left with as usual is this one, and this one, and this one. Yeah, so then this equals 2, and now it's going to be a square root si squared, and then minus, this is going to be r si, oops, r, erase that, yeah, r si phi squared plus r squared phi squared. And yeah, notice the difference or the similarities. This is si squared, then it's a negative rsi, then phi squared. Versus this one here, above this one, for the LO, is s naught squared, so si squared, and it's going to be plus rso phi squared. And the next one's going to be plus r squared phi squared. So that's what we have right now. Yeah, and now the next step is, well, now that we have these formulas for L naught and Li, so anticipating that we will use the binomial series expansion for the hint given, we can write our expressions for L naught and Li as follows. And remember the hint right here above. So the hint says use the first two terms in the binomial series for L naught to the power of negative 1 and Li to the power of negative 1. And again, the reason it's power of negative 1 because remember this is our equation 1. And we have this 1 divided by L naught. That's the same thing as L naught to the power of negative 1. And also this 1 divided by Li, and this is also 1 divided by Li, and so on. And binomial series is, we want to write this in a binomial series form, and I'll show that in a bit. And also use phi is approximate equal to sine phi. So let's just jump right in. So anticipating that we will use a binomial series, let's just write it down. So binomial series. And this is, let's just use the first two terms because I already have this ingrained in my head. So this binomial series is just 1 plus kx, 1 plus x to the power of k. And remember, it's going to be the binomial coefficients, which was, this is going to be approximately equal to 1 plus, the first one's going to be kx. The next one's going to be k times k minus 1 times x squared divided by 2 factorial, but we only want the first two, so this is approximately equal to this. So that's a binomial series approximation over there. And now we want to write this in terms of this, basically, because we have this power of, the square root is just power of negative 1/2. It's power of 1/2. We want this, we're going to have to do the power of negative 1/2 once we flip it upside down. But first of all, we're going to take this and we're going to try to rearrange it so that it looks like this. So let's just take this L naught, which is this one over here. So we get L naught. So this is approximately equal to, from our earlier approximation, square root, and this is going to be a giant square root of s naught squared plus r SO phi squared plus R squared phi squared, and we can just do a quick double check. This is a lot of terms, so move this over, and that is over here. So S naught squared plus R SO phi squared plus R squared phi squared. And that is exactly what we have here. Now what we're going to do is we want a 1 there to get this 1. So this is the obvious one, is the SO naught. S naught squared. So we're going to multiply top and bottom by SO squared over S naught squared. So nothing changes. We're multiplying by 1 so that we can move this in the front. Now this one we're going to divide this into both of these. It all goes inside the square root because they're all the same power, the square root. So this equals to square root S naught squared. That's just this top part. And now this is going to be, inside is going to be a square root. Now we're going to have a 1. So S naught squared divided by S naught squared is 1. The next one's going to be, well, R. And then the S naught goes away. We're just left with a S naught at the bottom. So R phi squared over S naught. Then this is going to be R squared phi squared over S naught squared. So that's what we have over there. Let's make a bigger square root sign, like that. And now this equals 2 plus or minus, and we're going to take the plus because it's a positive distance right there. But I always do this just because you can take a square root, it could be positive or negative, because negative times negative is going to be positive. Same thing as positive times positive. So now what we're going to have is, I'm going to factor out the phi, so 1 plus phi squared. Now we're going to have a R over S naught plus R squared over S naught squared. Put a bracket. And now this is our formula. Yes, that's our L naught. And now the next one is going to be our Li. So Li is going to be approximately equal to the approximation we had earlier, Si. So I remember this one. Minus R Si phi squared plus R squared phi squared. Like that. Alright, so we have this one right here. We can double check. That's this Si squared minus R Si phi squared R squared. Phi squared plus R squared phi squared. Same thing, multiply this top and bottom by Si squared over Si squared. Now we could divide by the bottom one. This is going to equal 2. Move this in the front. Si squared. Again, we're not changing anything. They're both, this is just unity. You're just multiplying by 1 in a different way. Multiplied by, so now this divides into, over here, it's going to be 1 minus R, the Si goes away, phi squared over Si, and then plus R squared phi squared over Si squared. And we could move this over. So yeah, before we get there, so we have this one right there. So I just fix up the square root sign. So now this is going to be, again, plus or minus, and we just take the plus Si. And now this is going to be, factor out the phi, so 1 over phi times it by R over Si. Now we're taking out a negative, so this positive is going to be negative, so R squared phi squared over Si squared, like that. And yeah, this is a squared there, so phi squared, like that. And put a square root sign to make this a bit better, like that. Alright, so now we can approximate L naught power negative 1 and Li to power negative 1 by the first two terms in their binomial series. As you can see, this can be our, this looks like our 1 plus x. Yeah, our 1 plus x to the power of k. All to the power of k, but this is square root to the power of 1/2. But we want the 1 divided by Li, so let's just do that right now. So thus, we get, let's just do our Li to the power negative 1. This equals to, again, just 1 over L naught, because that's in equation 1. And now this is approximately equal to our approximation above over here. So that's this one right here. 1 over, yes, it's going to be S naught there, but we're going to divide it, we're going to go divide this into 1. So it's going to be 1 over S naught. We just flip everything to the bottom. So 1 over S naught times by, now we're going to have a, let's put this in a bracket and use it as a power notation as opposed to this square root. It's going to be 1 plus phi squared. 1 plus phi squared times it by, and let's just use the square bracket here. So we have two brackets. Alright, so stop like this. Whoops. Okay, computer's frozen. Alright, just put the square bracket there. And now this is going to be, put the big bracket like that. This is going to be R over S naught. R over S naught plus R squared over S naught squared. and then put a bracket like that. This is going to be negative 1/2, because now it's, instead of square root, it's going to be negative square root, because it's you're dividing this you're dividing this into 1. So 1 divided by that, you just flip it upside down. Yeah, so now this is going to be our new x, and now this is going to be our new k. So now we could use the binomial approximations. So this is going to be approximately equal to, just put the 1 over s naught, and now replace this with our 1 plus kx. And now notice the beauty of this part. We removed this square root inside this because we just approximated with the binomial series of first two terms, and we got rid of the power. This whole square root, this negative square root. So now this is much, much simpler than having to deal with that square root. And that's why Taylor approximation is quite powerful. So now this is going to be 1 over s naught, and now add our values. It's going to be put square bracket 1 plus k, which is negative 1/2. And then now our x is going to be this whole giant thing. So it's going to be times by phi squared, and then we have a bracket r over s naught plus r squared over s naught squared, like that. Put a square bracket around it. Like that. So amazing stuff. And let's just box this whole thing out. So now this is our 1 divided by L naught. And now we could do the exact same thing for, or hide this up. We could do the exact same thing for Li. So thus, so let's do the same thing with this one. Li is over this one. I don't know why it's removed. Put a square root over there. Alright, let's continue. So now, so that we have that, and now we're going to put for the Li power negative 1 equals to 1 over Li. This equals 2, and let's flip this all upside down. So 1 over Si, and then we put a square bracket 1 minus phi squared bracket r over Si minus r squared over Si squared, all to the power of negative 1/2. So that's this part over there. And yeah, actually, just forget this. We have to replace this one there. So to replace that, it's going to be r squared. Like that, yeah, so we take out that phi squared out. Yeah, just like that. So that's what we have. I just did it here without even looking at that. So anyways, so that's what we have. And now this is going to be our new x for this case, for this approximation. This is going to be our k, which is the same thing. So then this approximately becomes 1 over Si times it by the binomial series first two terms, 1 plus kx. And again, we replace that square root sign. So now this becomes, so that negative square root sign becomes much simpler now. 1 over Si, and then we're going to have this, put a square bracket 1 plus k, which is negative 1/2, multiplied by x over here, but there's a negative over there, so it becomes positive. Two negatives becomes positive, times it by phi squared, and then we have this r over Si minus r squared over Si squared. Put a bracket like that. And now let's just box this whole thing out. So this is our 1 over Li. Yeah, so that's what we have now. We have all this, and now let's do put this all into equation 1. So that's equation 1 becomes, and let's just write equation 1 first, which was, let's see, this is equation 1 over here. So n1 over L naught plus n2 over Li, then equals to 1 over r times n2 Si over Li minus n1 So over Lo. So let's just jump right in and do that. So this is our equation 1. So n1, so n1 over So plus n2 over Li. This equals to 1 over r. And now we're going to put a bracket. And it's going to be n2 s1 over, no, I mean n2 over Si, n2 times Si over Li minus n1 So over, this is going to be L naught, like that. And this is our equation 1, and I'll just double check quickly. So this is our equation 1, and so we want equation 4. So we're going to plug in the new approximation using the binomial series and the and also the third degree Taylor polynomial and the second degree binomial series. So this is what we have. Let's just double check that again. Yeah, so this is what we have. So n1 over L naught plus n2 over Li equals 1 divided by r times n2 times Si over Li minus n1 times S naught divided by L naught, like that. So that's exactly what we have. And now we're going to replace all of these LOs and LIs, and this is a 1 over L naught. Like that. Yeah, so that's 1 over L naught. Let's see that again. Yeah, so L naught, not S naught. Okay. So now that we have that, just a bunch of subscripts. So now we're going to put this all into one. We're going to replace all this with approximation. So now we're going to replace this, with our approximation. So we're going to put N1, and then N1 is going to be times it by, well, 1 over L naught, and 1 over L naught is over here. So we're going to have an SO there. SO, giant bracket, 1 plus, 1 minus, 1/2 phi squared, and then those terms over there. So 1 minus 1/2 phi squared, and then this is going to be R over S naught plus R squared over S naught squared. Let's write this better. All bracket like that. And again, we don't have the square root anymore. So now this is going to be plus N2 times or divided by Li, or times by 1 over Li. So multiply by here. So this is going to be Si over here. And then this is going to be bracket 1 plus 1/2 phi squared times by R over Si minus R squared over Si squared bracket. Yeah, so now this is only just the left side of the equation. So now the next one's going to be, this whole thing's going to equal to this part here now. I'm going to multiply this 1 over R inside. So we're going to have a 1 over R, or actually, better yet, remove the 1, multiply this inside. It's going to be N2. N2, the next one's going to be Si, then divided by, well, Li is over here. This one's the Li, so we have an Si over there. So remember, Li has an Si. So it's going to be Si. And now we're going to multiply this by bracket 1 plus, and this whole thing is 1 over Li, so it's going to be 1 over 1/2 times by phi squared R over Si minus R squared over Si squared bracket plus, and then the next one's going to be, well, multiplying this 1 over R inside. That's going to be negative. It's going to be negative 1 over R times the side there. So we're going to have it as, alright, so we're going to have it as, this is going to be minus, and yeah, so N1 divided by R, so N1 over R times by SO over, now we're going to be, LO is going to be, well, this is our LO with that SO at the bottom there, so it's going to be SO there. SO bracket, now 1/2 phi squared R over S naught plus R squared over S naught squared bracket, close bracket. And now we're going to start having to multiply. Yes, so we're going to do that, multiply this out inside. So let's just keep scrolling down. This one's going to go down here. And now we're going to have to multiply this inside. So N1 over S naught times by 1. So we're going to have it as N1 over S naught times it by 1. So that's, yeah, this remains like that. Then we're going to multiply this, keep it going inside. Minus, it's going to be as N1 at the top, phi squared over 2 S naught, and bracket R over S naught plus R squared over S naught squared, bracket, plus, now multiply this inside over here. So we're going to have a N2 over Si, and multiply this again, plus, it's going to be N2 phi squared over 2Si, and then multiply this out, R over Si minus R squared over Si squared, like that. I'm going to erase this over there, like this. And then, yeah, so that's what we have over here. We don't need that second square bracket anymore. And now we got to account for the right side. So this is equals 2, and these SI's cancel. And this SO's cancel. Yeah, so now we just multiply this inside. So we're going to have a N2 over R. So multiplied by 1 is just that, N2 over R. Multiplied, keep going. It's going to be plus N2 phi squared over R. Now the next one's going to be, well, we have this other bracket, R over Si minus R squared over si squared. And now this is going to be minus. Now multiply this n1 inside there. It's n1 over r. Then multiply inside there, so the negative becomes positive. So n1 phi squared over 2r, and then multiply this out by r over s naught plus r squared over s naught squared, and then put a bracket. Alright, so now the next step's going to be, well, we're going to have to just collect like terms and get the left side as the equation 4, which is just this one and this right here. So this and this by itself. So we're going to have these ones by itself. So we're going to have n1 over s naught, like that. And then plus n2 over si, just the usual equation 3 and equation 4. And so this is going to equal 2, and we're going to move this over. So this, remember, this one's a like term as this one's like with this one. So we're going to, it's just going to be subtracted here. We're going to add on both sides. We're going to add this over to here, and over to this one. But before that, this and this are similar, so keep those together. This is going to be n2 over r minus n1 over r, like that. Yeah, so now what I'm going to do is I'm going to move this one added over to this one. I'm going to put this in front and also factor out the like terms, which is, these are exactly like terms. n1 phi squared and this one over here. No, actually, never mind. Those aren't the like terms. The like terms are these underlined. Yeah, so this one's we're going to factor it out. So what we're going to end up having is, and this is, we're going to add to this one on both sides, so it's going to be a plus. So we're going to have a bracket plus n1 phi squared over 2s naught plus on this side now. Plus n1 phi squared over 2r, and then put like bracket like that, and this is going to be the one that's factored out. S naught plus r2 s naught squared, and now we keep going, so this is going to be a plus or minus. Now we're going to do the same thing with this si there. So this one here, I'm going to put this over here, and this one, these are the like terms, so we're going to subtract it on this side to get it over to here. And also, yeah, we're missing something here. I just realized that there's a 2 there. So remember, over here we have this n2. That's, let's see, that's this part right here. So n2 over r times it by 1. Then n2, we have this extra 2 there. So this is going to be a 2 there. Yeah, so that's a 2 there. Just to, I would have messed up everything if we didn't have it. So we have this one now. And now we're going to subtract this and collect the like terms, which is this one. So this is going to equal to, well, it's going to be a plus. Let's keep it the plus. So we have this in front. n2 phi squared over 2r. And then minus, this is going to be over here. n2 phi squared over 2si. And then bracket r over si minus r squared over si squared, and then bracket. So now that is what we have. And now the next phase is, I'm gonna just shift this over so it's away from this equal sign. Let's put it over here. So yeah, so it's plus that, and then equals 2. Well, now we can start simplifying a lot. This equals 2, and this is going to be again n2 minus n1, the same common denominator as r. Now what we can do is factor out this n1 phi squared over 2. That's exactly there, which is going to be left with this SO and R. So it's going to be plus n1 phi squared over 2. Now we have a 1 over s naught plus 1 over r times it by over there r over s naught plus r squared over s naught squared. And now the next one is at the bottom over here. We could factor out this n2 phi squared over 2. So that's going to be plus n2 phi squared over 2 multiplied by 1 over r minus 1 over si. And now we have over here is going to be an r si minus r squared over si squared. And now what we're going to do is we're going to factor out this r squared out. Yeah, we're going to factor that out. So this is going to equal 2. So we keep going further and further. So n2, this is a lot of algebra, but it's pretty fun indeed. So n1 over r. And now we're going to factor out this r squared on this side. It's going to be a plus n1 phi squared over 2 1 over s. Actually, we're going to factor out the r. I'm just going to put an r squared now. R squared, yeah, like that. And now it's going to be a 1 over s naught plus 1 over r. Now this one here is going to be refracting out the r. We're taking r squared. This one has an r there, so we're going to have a 1 over r s naught. Yeah, and likewise then, that means we're going to have to factor out the s naught as well. So we're going to factor out 1 s naught out of there. So it just becomes 1 over r plus, now that we're going to factor out r squared and s naught, so we're going to have 1 over s naught. Yeah, and here again, remember, if you multiply r squared over s naught inside here, you're going to get r squared over s naught, the r's cancel. So yeah, so we can do that. Now the next one's going to be, and now here I'll just do a little illustration. Here, i.e. r squared over s naught times by 1 over r equals 2. Well, this cancels r over s naught, which is just this part. So yeah, so just circle that. Just wanted to show what I meant by that. But it should be pretty straightforward anyways. So next one is, so that's what we have there, plus, now this next one here, we're going to factor out r and si. I mean r squared and si. So n2 phi squared over 2 si, and this one's going to be an r squared like that. Yeah, let's just expand this one out. And now this is going to be 1 over s naught plus 1 over r. And now, actually no, that's this one over here. Got it upside down. That's this part here. Alright, let's continue back to this one. Yeah, so it's this one over here. 1 over r minus 1 over si. Now we factor it out over here. So we factor out an r squared and an si. So we're just going to be left with a 1 over r. So you have to have you took an r squared out, so you divide by r. Minus, now take the r squared and 1 si, so 1 over si. Like that. So that's what we have here. And now, lastly, let's factor out the like terms between these two, and that is our phi squared and r squared. So that we can factor those out. So this equals 2. Let's see if we can write it in one line. n2 minus n1 over r. Like that. Alright, just fix that up. This is going to be plus, and then we're going to have phi squared r squared. And now we're going to have multiply this by... yeah, by close bracket, and then we're going to have an n1 over 2so. Yeah, I just left a 2 there just because the equation 4 left it in. So this is going to be now 1 over s naught plus 1 over r naught. And then this is going to be... actually, yeah, we just realized these are the same thing. 1 over r minus 1 over si is the same as 1 over r minus 1 over si. And here 1 over s naught plus 1 over r. And then 1 over r plus 1 over s. Oh, that's just squared. Yeah, so just square that. Then plus, and the next one's going to be, well, this is going to be an n2 over 2si. So it's supposed to n1 over 2so. n2 over 2si over 2si times it by 1 over r minus 1 over si. All squared and close bracket. And yes, that's what we have there. And let's just bring down what this was. So n1 over so plus n2 over si. So this is going to be n1 over so plus n2 over si. Yeah, like that. So that's what we have over there. Put this as a subscript. Alright, so now that we have all this giant formula, the next step is now to apply the second hint that we were given, that is to use the approximation phi is roughly equal to sine phi. We first need to look at the refraction figure again, and the reason for that is let's just scroll up. So this is what we have so far, but equation 4 is a bit different. Yeah, so here I'm just jumping all the way to the refraction graph like that. So we need to, we have this phi like that, and the equation 4 had, let's just go to the equation 4, had an h in there. So here's equation 4, there's an h squared there. Remember, h is the height. So to account for the height, well, we know that there's the h there, there's the phi, we could use sine. So sine of phi is equal to h over r, the opposite over hypotenuse. So there is our h. So now we could approximate that. Now we can jump back in. Alright, so now let's just see what if we memorize it. So we have our spherical interface like that. We have the point A, and then we have the center of this circle C. Is C like that. This is distance here is r, same thing as here is r. And now this height is h, like that. And again, this lines up with our starting point S, but we do not need it. Yeah, so that's just our starting point S here, or our starting point of the wave. But anyways, all we need is over here, and we know this is phi. So that means, well, sine phi is opposite over hypotenuse. This equals to h over radius r, like that. So thus if we were using the approximation phi, yeah, so put it over here. So thus, if we're approximating phi is roughly equal to sine phi for small enough angles, this is going to be equal to or h over r. So that means then we could just solve for our we could solve for our h value. And what I mean by that is, well, we know that in our equation we have phi and we have r, and we have a phi and we have an r. So just move this over to this side. So this becomes, yeah, so then this becomes over here, and yes, move it over there, and this whole thing becomes h is equal to, well, since it's an approximation, so h is roughly equal to phi r, like that. And then now if we square it, so then if we square it, h squared is roughly equal to phi squared over r squared. So in other words, we have a value for h. So this is, I'll box this out like that. And then this is h. This is h squared. So if we could replace the whole thing with h squared. So thus, yeah, so now plugging this into our derived formula above gives us the desired equation 4. So let's just write this whole thing out. So it's going to be n1 over s naught plus n2 over si equals 2 n2 minus n1 minus n1 over r, like that, plus this is going to be now 8. This is h squared. So plus, yeah, this is going to be plus, this is h squared now. That's our phi squared. Then we just put this inside here. So n1 over s, n1 over 2 s naught, and then bracket 1 over s naught plus 1 over r squared, plus the next one's going to be 2 n2 over s I. So see, that's right, n2 over si, then 1 over r, 1 over r minus 1 over si, and let's just box this out. Yeah, put a bracket like that. This is going to be squared, and all boxed in like that. Yeah, so this is what we have now. I'll box it all out, and let's just double check one last time with the equation 4 all the way up. Let's keep scrolling up. Where is our equation 4? That's equation 3 and equation 4. So there's the n1 over s naught plus n2 over si. Then n2 minus n1 over r plus h squared times my bracket, box bracket, n1 over s2, n1 over 2so times so plus 1 over r all squared plus n2 over 2si times 1 over r minus 1 divided by si, then all squared. Like that. And it looks like it's exactly it. Yeah, and here's teleport here, and it looks like exactly the same, so I'm going to put a check mark. If you see any errors, let me know. Or don't let me know, because it's pretty good. I'd rather believe it's all right.